Thank you, William. And hello, everyone. I'm very happy and excited to be here. I must say, every time I have a chance to say that about GroupBy, I will say it. I love this event, GroupBy. It's the only one I know that is true democracy. Like the community chooses the sessions. There is no one that decides what will go in, what will go out, unlike most other conferences. And I really like that. We have exactly what we want. I love it. So this is me. Well, sort of. My name is Guy. I am based in Israel. I'm the CEO of Madeira Data Solutions. We provide data solution services around the Microsoft data platform and specifically SQL Server, but not just SQL Server. I'm a data platform MVP for Microsoft. I lead the Israeli data platform community. We have a data platform meetup in Israel, which is a PAS local group. I also co-host alongside Eitan Blumin the SQL Server radio podcast, if you're familiar with that. If not, and you like SQL Server, then go and check out sqlserverradio.com. We talk about SQL Server stuff, new features, projects that we do with customers, events in the community. We interview guests once in a while. We had William as a guest a long time ago. And I'm also a SQL Server fan. I love SQL Server. I've been working with SQL Server for the past, I think, 22 years, 23 years, maybe something like that. So I've seen a lot of things. I've done a lot of mistakes. I've learned a lot along the way. And I'm here to share from my experience with you as much as I can. Now, a few things about the session today. It's called SQL Server Setup Best Practices. First of all, I know it's the performance track. So I think most of the best practices that I will show you here are related directly to performance. You will benefit from better performance if you follow these best practices. Some of them are not specifically about performance, but just in general, what you should do when you set up, when you install a new SQL Server instance. So the other thing I want to say is we focus here on SQL Server on-prem. It doesn't have to be specifically on-prem. It can be, of course, SQL Server on VM, in the cloud, in Azure or in Amazon or whatever, but it's not a managed instance or a SQL database in the cloud because we focus here on the installation, on the setup. Things you should be doing, best practices before installing SQL Server, things you should be doing during and also after. Some of the things I'm going to mention here probably also related to a managed SQL instance in Azure, but not for SQL databases, but mostly I will talk about SQL Server on VM or SQL Server on-prem. All right, so we have the SQL Server. Just like I said, there are some things that we need to do before even starting to hit next. We need to plan, and I'll talk about that. Several things during the next. Instead of just clicking next. You need to pay attention to some things and configure things in a proper way during installation. And there are several things that you want to do, you should be doing after installation. And I will show you what I mean later. So let's begin. Number one, we are currently before, okay? We are still in the planning phase. So number one, choose the appropriate SQL Server version and edition. I just did another session. It's a busy day today. 2 hours ago, I finished another session for the local community about how to reduce database costs, which during these times is a very common issue. One of the things I talked about is to choose carefully the SQL Server edition. There are many cases where customers use standard while they actually can and should use developer edition or express edition, or instead of enterprise, use standard. There are all kinds of use cases that by carefully planning and using the appropriate licensing, you can save a lot of money. Of course, in some cases, what you really need is enterprise edition. You need a full stack of features, high availability, performance, security, and so on. So it really depends. So you need to plan before you start what should be the edition that you want to use, and also the version. There are all kinds of opinions about that. One might be always choose the latest version. Okay, so as of today, it's SQL Server 2019. And usually I would say go with the latest version. If you're going to upgrade or to install a new server, why starting from something that is already old and not being on the latest version, enjoying all the latest features? So start with SQL Server 2019. Some people might say, wait for the first service spec. So this is not relevant anymore. We don't have service specs anymore for SQL Server. Today, it's only cumulative updates. Okay, so you might say, okay, let's wait for the first cumulative updates, or the second one, that's okay. With each version, we have different bugs. With each cumulative update, we have different bugs. Some bugs are fixed, some others are not. So it really depends. Sometimes you don't have a choice because you have a third-party application. You have a vendor that only supports SQL Server 2016, for example. Then you need to take into consideration all of this. Okay, so you really need to choose which one you want, version versus edition. Prefer the latest version, as I said, if you can. Check compatibility. Okay, so if you have an application that only needs to work with a specific version and it will break with 2019 for some reason, of course you need to test, you need to check that. I put here a link. I'm not even sure, William, can you help me with that? Where am I going to upload the presentation later to make it available for people? In the GroupBy website?
I believe it'll be on the GroupBy website. I'll find that out at the end. I'll give the full answer.
So I'll make it available on my blog as well, just in case. Okay, so you'll be able to access it later and use all the links that appear here throughout the presentation. So this is a link to Microsoft documentation, comparison of features between SQL Server editions and various versions. So you can check and decide which one you need or you want. So this was the first one. Okay, plan ahead. Don't just say, let's go with 2019 or whatever, because it has implications. Number two, still before installation, still in the planning phase, plan for capacity. This is really important. I see many times customers fall in that trap. They start small, everything is okay. At some point, you don't have enough resources. Either the production server that we started with is not strong enough, and now we need to do a migration, which might be not such a good idea when we are in production, or we don't have enough storage and we need to buy more disks, whatever. Okay, so plan for capacity in advance as much as you can. I'm talking about, of course, the resources, CPU, memory, storage, also networking. Sorry, before that, you need to take into account first the specification of the specific machine you're going to use. Again, whether it's on-prem or a virtual machine in the cloud. Plan ahead. Sometimes it's an existing application that you are going to migrate to a new server, and then you're lucky because you can monitor the existing application and you should be able to know more or less how many cores you need, how much memory you need, and so on. Sometimes it's a completely brand new application. You have no idea what's going to be. You still need to come up with some estimations, and you need to decide how far are you going to plan ahead. 1 year, 3 years ahead, and take a decision about that. Or, of course, you can go to a platform as a service or a pay-as-you-go model in the cloud where you can easily scale up and down if you need to in the future. So it depends. But if we're talking about a SQL Server instance, a virtual machine, you need to plan ahead. Also, storage capacity. You need to take into account how much, what would be the size of the database, let's say 1 year from now. And it's not just the size of the data, because you also have indexes, and you have backups, and you have Tempdb, and maybe you have archive, and you need to multiply. You have a replica because you need high availability, and so on and so on. So you need to think about all of that, take everything into account, and plan that you have enough storage. I see too many cases where customers run after storage. They don't have enough storage. They have to shrink all the time, delete files, move things around. They waste a lot of time and resources instead of that buying enough storage for the next year and just don't deal with it, okay? Which I think this is how you should be working. So that's about capacity. Number three, still before, as a best practice, if you can, install SQL Server on a dedicated machine. Now, of course, it depends, okay? If it's a busy production environment, you really don't want to mess it up with other things. SQL Server needs its own resources. It needs memory. It will take everything it can from the operating system. Let it take it, let it work by itself. If it has to compete with other services and applications, this might cause you some issues in production. Of course, if it's a small scale application, maybe it doesn't make sense to put different services or different processes on different servers. You want to put everything on the same server, and if it's good enough for you, that's fine. But I see with customers cases where they put things on the same server and they waste a lot of time to try and troubleshoot problems, issues of performance with each one of the processes, and they change settings all the time, and it never ends, okay? So if you can, just give SQL Server its own dedicated machine, let it use all the resources. So if we have a SQL Server, I see customers run sub-applications, SharePoint, or any other service or process on the same server, and they don't work well together in many cases, okay? So don't. Next, plan and prepare the storage layout. Okay, so we talked about storage capacity before. Now let's talk about the storage layout. It really depends on the type of storage that you have. You might have local disks on your server, or you can use a SAN storage, or if you're in the cloud, then it's cloud storage somewhere. It might be physical disks, virtual disks. There are all kinds of setups that you can use. Generally speaking, we want to be able to split the files that we use for SQL Server into categories. One category would be the data files, the MDF, NDF files of the user databases, and then the log files, the LDF files, Tempdb data files, and Tempdb log files. Tempdb is a very, very busy and critical resource in the SQL Server instance. We want to protect it. We want to give it good resources. One of the things we need to do is to put it on separate drives, separate disks, and also backup files. If you have a backup, you should have a backup mechanism that creates backup files on some disk. Put it in a different disk. Don't put the backups, all the I/O writes and read from the backup in the same disk that is also used for data files or log files, and some others depending on what you use. If you use, for example, memory optimized tables and you want to persist them, there are other types of files that you might want to put on a different disk, and others. Maybe file stream, you manage files in a file table. You want to put that on a different storage, and so on and so on. All kinds of different categories of files. Now, if you have a server with local disks, depending on the amount of disk you have, you can configure them in all kinds of ways. Depending on your storage layout, you want to split as much as you can the different types of files. If you put everything on a single disk array striped among all disks, then it doesn't really matter as far as performance, because everything is anyway on all of the disks. But when we talk about monitoring and troubleshooting, it still has meaning, because if you look at, depending on the monitoring application that you use, you might, let's take performance counters, performance monitoring in Windows, for example. Then you have performance counters for specific disks. You can look at logical or physical disks. And even if everything is on a single stripe of disks, you say it doesn't matter. If you put them on different logical disks, then using performance counters, you can track, you can monitor specific disk. If you have a specific logical drive, let's say drive E, for the data files, for example, and you know that you only put data files on drive E, looking at the graphs in Performance Monitor, you can distinguish between the data files, the log files. You can see where you have issues and what's causing your I/O bottlenecks, and so on and so on. So not just performance, but also monitoring and troubleshooting. As a best practice, split those types of files into separate drives. And of course, this would be best before even starting the installation. Prepare all the infrastructure, all the layout before you even start with a SQL Server setup.
Okay, Guy?
Yes.
There is one question on this. Should we separate the log files and data files of Tempdb on different disks, as mostly I come across one disk for all Tempdb files?
Yeah, well, again, as a best practice, if you can, split them as well, because the same reasons. Data files are mostly random access. Log file is sequential. Even in Tempdb, it's the same thing. If you can put them on different disks, then one disk only serves the random access for the data files of Tempdb, while the other only serves the log file. You will get potentially better performance from that. And also, again, like I said before, for troubleshooting purposes, again, it's a best practice. I know that many blogs, many articles say put Tempdb on a separate files, data and log together. It might be good enough, but again, if you can afford it, or even if you not just if you can afford it, even if it's on the same physical disk, like I said before, just split them into logical drive just for monitoring sake. Why not? Okay, so I still think you should split the data files and log files of Tempdb as well. All right. Any more questions, William?
No, that's it just at the moment. Thank you.
All right, so we are done with the before phase. Let's move to the during. Okay, so now we put the media, the SQL Server setup. We started the installation. Several things we need to consider and take into account before we just click next. So one of them, only install the required features. Okay, so this is part of the setup. We get all the different features. Sometimes people just select everything because why not? Okay, that's fine. But remember that first of all, they consume some storage space. It's not a big deal. But in many cases, people also forget to configure the services correctly. And if you have, for example, analysis services, it's configured to start automatically every time the server starts, so it's always up and running, but you're not really using it, it consumes resources. And if you really need those resources for your database engine, you don't need it. So either you just put it in disabled mode, or at least don't even install it in the first place. Okay, so only install what you need. You can always put the installation media, the SQL Server. Actually, you don't even need to put the installation media. You can start it from the server itself. You have the installation center. You can go into the setup, go back to this page, this step in the wizard, and check the features that you want to add to your installation. Next, choose the appropriate instance collation. Okay, now this might be unfortunate if you choose the inappropriate collation, because once you choose the collation for the server, for the instance, you cannot change it. And what's important to take into account about the collation, of course, if you only use English and you don't care about other languages, and you will never care about other languages, then probably it doesn't matter for you. But in many cases, you do care. And one thing you have to be is consistent. If you have multiple databases, or even a single database on the instance, you want the instance collation, the server collation, and the database collation to be the same. You want that to be the same because if you don't do it, Tempdb uses the instance collation. So what might happen, you might create a temporary table somewhere in your user database. The temporary table has some nvarchar column. It's created in Tempdb using the default collation of the server. And you might do a join and compare it to some column in your user databases, which uses the default collation of the user databases. If they are not the same, you will get an error in some cases, depending on what you do. This might be a problem. So you want your collation to be the same as much as possible. This is one thing. And another note, I've seen it in some cases, people, usually it's accidentally, they choose a collation that is case sensitive for the instance. This means that all of your system objects, all of your objects, your table names, view names, top procedures, all of the names are now case sensitive. And it can be really annoying. You don't want that, mostly, at least in my opinion. So make sure that you use an insensitive case collation for the instance. Next, enable instance file initialization. This is a hard name to pronounce. It's really important. Instance, let's call it IFI, okay? IFI means just for data files, not for log files. If you need to create a new database, you need to add a new file, or maybe you need to increase the size of an existing file. Every time you need to allocate pages for the file from the disk, from the file system, by default, what the file system, the operating system does, it will zero out all the bits for you, okay? Here is a blank page, now you can start using it. This might take a lot of time. If you want to create a new file with a terabyte of size, or you want to increase an existing file during production with a few hundred gigabytes, it might take a lot of time to zero out all the bits. And you don't want that. You want it to happen instantly. With this feature, it happens instantly. This means that the operating system will not zero out all the bits. It just allocates this space from here to here. This is yours. Start ahead. You do that by, I think it started in SQL Server 2016. During the setup, it's part of the wizard. You just need to put the checkbox and it's done for you. If not, if you're in a low version, or if you didn't do it and you want to edit later, what you need to do is go into the local policy of Windows and find the grant perform volume maintenance task privilege, as you can see here. And you need to grant the SQL Server service account, the one that is running the account for the database engine. You need to grant it this specific privilege, and this will create this feature for you, IFI. Again, just for data files, not for log files. If you need to increase the transaction log file, it will still need to zero out all the bits. Now, the use cases are, again, adding a new file or creating a new database, increasing, it might be an auto growth or manually increasing the size of files, and also restoring, which is critical, because if you are in a crisis, you had a crash, and now you are in downtime, you need to restore from backup, it might take a lot of time to restore, because during the restore, the first phase is to allocate the space on this based on the original size of the data files. And now we need to zero out all the bits. This might take a lot of time before writing into the new files. With this feature, with IFI, the restore is much faster. You have less downtime. So this might be critical. And last thing about that, you need to remember that there is some security risk. If there is critical, important, confidential data on disk from a previous file that was there, if you're not going to zero the bits, you might have a potential security breach there, because someone with privileges in SQL Server might access the content of those pages and get data from there. Okay, so sometimes it might be a problem. You need to consider, of course, your specific scenarios, but in most cases, you want this feature for better performance. Okay, so this is instance file initialization. And I put here the link that you get from the setup. If you need more information from the Microsoft Docs to read about it, how it works, how to set it up, and so on. Next one, leave enough memory for the operating system. This is really important. It's a known issue. Most people know it. If you don't, then I'm glad you're here. It's really important because by default, when you install SQL Server, during setup, I can show you, here's the default. So by default, you have min server memory and max server memory. These are two properties at the instance level that you can configure. It actually determines the size of the buffer cache, the buffer pool for SQL Server, what size it's going to use. By default, the min server memory is 0. The max server memory is what you can see here. It's the max of integer. It's 2 terabytes, petabytes, whatever, something, I don't know. Anyway, this is default. It practically means take everything from the operating system. So let's say you have a server with 256 gigs of memory. SQL Server by default will take everything. It will start low. It will take more and more memory. If you have large enough database and you have to put everything in the buffer cache at some point, SQL Server will take everything from the server. This means that the operating system, Windows, for example, will not have enough memory to operate. This might cause problems. So it sounds like a good thing to give SQL Server as much as possible, but you get it in the backdoor from Windows. You get some signals for low memory pressure, and this might hurt performance eventually. So what you need to do, you need to balance that. You need to leave some memory for the operating system. So there are all kinds of recommendations out there in the wild. You can read different blogs. Different bloggers have different opinions. The most common, I think, and this is what usually I recommend, at least as a starting point, is either to leave 4 gigs or 10% of the physical memory on the server, whichever is larger. Okay. So in the case of 256 gigs, 10% would be around 26 gigs. This is what you're going to leave for the memory for the operating system. This means you're going to configure SQL Server to have a max memory of 230 gigabytes in this case. Again, starting from, I think, SQL Server 2016. During setup, we have this during the wizard. We have the default, we have recommended. So SQL Server already calculates for you the recommended. I wish this was the default, but this is recommended. And you need to specifically, explicitly say, I want the recommended. And you see the checkbox down there. Click here to accept the recommended memory configuration. So you need to do it explicitly. And again, I put here the link to the Microsoft Docs that explains how SQL Server, how Microsoft calculates the recommended max memory. But again, as a starting point, you should either use the recommended during setup or use what I said here, 4 gigs or 10%. I say starting point because every workload, every scenario is different. So after you install SQL Server, you finish with the setup and you start using your application, you should monitor and see how much memory SQL Server really uses, how much memory pages you have, how many signals of low memory you get from the operating system. What would be the PLE, the page life expectancy over time. You need to monitor those and take actions, either increase or decrease the max memory as. And again, always monitor again and see if it improves or not until you get to the more or less the optimal value for your specific environment. But this would be a good starting point. Whatever you do, don't leave the default. Don't give it just everything, because this will almost surely cause you troubles. Okay. Instance configurations. There are all kinds of configurations at the instance level. I'm talking about either sys configurations or the spconfigure command. With the spconfigure command, you can change different configurations. I have here a table to show you most of the configurations that I think you should change, that the default values are not the optimal values in most cases. Okay, so let's go and check them one by one. The first two, I'm going to leave that for later. I have specific best practices talking about cost threshold for parallelism and max degree for parallelism. Those two talk about parallelism in SQL Server. We'll tackle them later. We just talked about max server memory. This is part of the configurations, so we talked about that. Several others which are just true or false. There are 4 configurations that are disabled by default, and I recommend you to enable them as a standard, as a best practice. One of them is connections. Okay, so it's not related to performance in this case. It's related to availability of your server. If something goes wrong and you can't connect to your SQL Server, and this can happen for various reasons, you still have the duck. The duck is the dedicated administrator connection. This is a connection that is reserved only for users with a single user with sysadmin privileges. And if you are the DBA, you are the sysadmin, then you might still be able to connect to your SQL Server with this duck, with this kind of backdoor, which has its own reserved resources to allow you to connect. And then when you connect, you can troubleshoot and do whatever you need to do in order to allow all other users to go in before you do a reboot of the entire server or the service. So this might be very useful. By default, remote admin connections disabled means you can only connect with the duck locally. You have to first remotely connect to the server, RDP to the server itself, and then you can open a duck connection. Sometimes it's not possible, okay? If you cannot connect to SQL Server, there is a good chance you can't also connect to the server. You can't RDP because it's too busy, something happened, I don't know. You want to be able to connect remotely to SQL Server using the duck, and for that, you need to enable that configuration, okay? Of course, you might have a policy that says you can't. You have a regulation, I don't know, so you need to check that, but if not, this should be a best practice to enable it before you even start using the application. Next one is backup compression. Backup compression is one of those features that I really don't see why not using them always. Okay, so you might say in some cases, the CPU overhead of having to compress and decompress is higher than the benefit for compressing. I've never seen such a case. Usually the CPU overhead is really, really small. But you might gain a lot of benefit from 2 things. First, storage footprint. Okay, the size of the backup files will be much smaller than without compressing them. And also I/O. When you need to restore a compressed backup, it will take a lot less time because you need to read less pages. And this, again, might be very, very critical when you are during downtime. So I think you should always prefer backup compression by default. And this is what this configuration means. Now, you'd better be explicitly specifying whether it's using a script, application, whatever, using your backup mechanism. Make sure that explicitly you specify there to compress the backups, just in case, okay? What this means, if you forget to do this explicitly, it will take the default value from this configuration. So also make sure that by default, everything should be compressed. Next one is interesting, optimize for ad hoc workloads. Now, this one talks about ad hoc workloads. I'm talking about queries that the application sends to SQL Server without parameters and not SOAP procedures, not parameterized queries, just ad hoc queries with explicit static values inside them. And some applications are built that way. They dynamically build the applications and send them to SQL Server. And if this is how your application is working, then it has some issues with it, because you might have a query with a specific parameter. The parameter value can be millions of different values. This means you're going to have millions of different queries, which are practically the same. All of them should get the same execution plan. What will happen, you'll have millions of compilations, and each one of those execution plans will have to go into the plan cache and consume space in memory, consume memory. And of course, you don't have enough memory for millions of execution plans. You will have to recycle them. You have to throw something out, either from the plan cache or even from the buffer pool, from the data cache. Some data pages that you really need them there, they will have to go out because you need room for the plan cache for new execution plans. This is not good. You're going to get poor performance because of that. One thing you can do, of course, the best thing to do, the best practice is not to do this, is to rewrite your code, to redesign your application, to use either SOAP procedures or at least parameterized queries. Add parameters to your queries and use values with parameters, not static values each time. When you use parameters parameterized queries, the first time such a query comes into SQL Server, it will generate an execution plan, like a template execution plan for using this parameter. And the same query with different parameter values will reuse the same plane. So you save a lot of compilations, a lot of CPU resources, but also a lot of memory, because now you have only a single execution plan in cache instead of millions. This can be critical. If you can't do that, or you're too lazy, you don't want to rewrite your code, what you can still do, it's not the same thing as rewriting, but you can enable this configuration optimized for ad hoc workload. And what this means is that the first time an ad hoc query without parameters comes along, if it's not, if it wasn't there before, SQL Server will of course generate a plan for it, execute it, but it will not save the execution plan in the plan cache. It will only take a hash value of the plan and it will put a stub, which doesn't consume much space, in the plan cache. If the exact same query with the same values comes again later, SQL Server will recognize the hash value, the stub in the memory, in the plan cache. It will have to, of course, recompile it a second time because we threw away the first one. But now, because it's the second time, it's going to put the execution plan in cache. And from this point onward, we're going to reuse the same execution plan if it's the exact same query. This way, if we have only single execution queries coming, we will not waste memory for them. But if we encounter a query that comes at least 2 times or even more, then we want to reuse the plan for it. So starting from the second time, we will store the plan in cache. So this improves memory management for the plan cache in such scenarios. Many bloggers out there, including myself, recommend that always, or at least in most of the cases, you should enable this configuration by standard, because the downside of it is usually quite small. You don't really lose too much from that. And in every application, in most workloads, even if you're using stored procedures, you always have some ad hoc queries. Some part of the workload is ad hoc queries, and they might benefit from this configuration. So you might benefit from it without paying too much cost. Again, of course, every environment is different. You should test, consider, blah, blah, blah. Yeah, you got me. The last one, backup checksum default. Just like backup compression, it's also about backup. Whenever you do a backup, by default, this is disabled. I think you need to enable it. This will mean that SQL Server will calculate the checksum, like a hash value for the entire backup file, and put it in the header of the backup. This is good because if something goes wrong with the storage, you have some kind of corruption, and later on you want to use that backup and it's corrupted, you will not be able to use it. If you have regular tests, you want to test your backups, thanks to this checksum, you might realize that you have a problem, because when you read the file, you calculate the checksum again, you compare it to the checksum that was stored previously in the file, and then you might realize you have a problem even before you try to perform the entire backup, okay? The overhead is like nothing. I don't see a reason not to use it. So I think, again, as a standard, as a best practice, always enable this configuration. Any questions so far, William?
Yes, there's a few. I've had them all in the queue ready just to get it at the right time. So first question, does SQL Server best practices for VMs differ from best practices on bare metal?
Ooh, great question. Generally speaking, as far as SQL Server is concerned, it is not aware whether it's on a VM or on a physical. That's the whole idea of virtualization. So as far as SQL Server configuration and so on, it doesn't matter. You have to configure it the same way. What does matter is if you handle it yourself, if you manage the hypervisor, whether it's Hyper-V or VMware, from my experience, you need to have someone who is really experienced, who's really expert in virtualization. And I'm not an expert in virtualization, but I've seen many cases where customers use virtualization and they had all kinds of problems, performance problems, because of not allocating resources properly between the different guests. And when someone who is an expert comes along and does things the right way, whatever he does, I really don't know, I'm not an expert in that field, suddenly things go the right way, everything is much better, okay? But as far as SQL Server is concerned, it's the same from the SQL Server perspective.
Yeah, completely agree on that one. Somebody who's really good on that sort of thing is a guy called Klaus Aschenbrenner.
Yes,
I'll write that
right.
into the webinar chat so you can find his name. He's an Austrian,
Yeah,
and he's done a heck of a lot of work using SQL Server on VMs and has some really good content on that.
right.
Okay, next question. How does max server memory need to be tuned if we also run SSRS, SSIS, and or SSAS?
Thank you for that question. Okay, there are several things I wanted to say, but I forgot. Great. So if we talk about those services, report server or integration services, for example, those are services, they are processes external to the SQL Server, to the database engine. I treat them just like any other external processes. Just like I said, you have SAP or SharePoint or whatever, it's the same as far as I'm concerned. Now you have two processes, let's say SSIS, and you also have SQL Server. Both of them need a lot of memory to consume, and they compete with each other, and you're going to have some issues there. Generally speaking, again, if you can afford it, put SQL Server on a dedicated machine, put your SSIS or your report server on a separate machine, each one with its own resources. That's one recommendation. If you're still going to put them, let's say, again, SQL Server and report server on the same machine, then in those cases, if we talk about the max memory, when I talked about max memory, I talked about what you should do when SQL Server is the only service on the server. Okay, then only leave 4 gigs or 10% for the operating system. Of course, if you have other things, you need to do more fine tuning. You need to monitor and see how much memory each one of those services really need. And then by configuring max memory for the SQL Server, allowing enough memory for report server, for example, then of course it's not going to be just 4 gigs. Maybe it's going to be 20 gigs or 30 gigs. I don't know. It depends. It really depends. You need to monitor. I cannot give you a right answer, a specific number. Also, in these cases, you might want to use mean memory. Mean memory is something that usually you shouldn't touch. Leave it as 0. Don't touch it. Mean memory means when SQL Server starts, it will allocate the mean memory that you specify. It will never give it back. Okay, we're gonna keep all those, let's say, 20 gigs for itself. When you have competing services and you want to make sure that your SQL Server, your database engine, gets enough memory at all times, you might want to use mean memory to make sure that the report server or whatever else is running there will not take too much memory from SQL Server because they compete with each other. So you want to play with both of them, mean memory and max memory.
Fantastic. Okay, we got 2 more questions. How do you know the required value for cost threshold for parallelism and max DOP?
Excellent question. I'll get to that. I have slides for that.
Fantastic. Okay. Final question then at the moment. When using a third-party backup software, I have seen that the compression ratio is much higher than using SQL compression. Is the backup compression, or will the backup compression interfere with third-party backup tools? So the setting to backup compress.
I'm not sure what it means by interfere.
So I think if I understand it correctly, if we turn on backup compression by default,
yep,
and then we run a backup using a third-party tool, will the native compression interfere with third-party backup compression?
Oh, okay, I see the question. So when you use a third-party backup tool, depending on the tool that you're using, generally speaking, there are 2 methods for backing up a database in SQL Server. One method is to use T-SQL, use the native backup. So you might have a third-party tool that actually runs T-SQL commands and doing a backup database, and so on. And when it's doing a backup database, it's going to use the native backup compression. Now, depending on your third-party configurations, you probably need to configure it to use the backup compression, but this is the native one, and it's the only, it doesn't compete with anything. It's the only one you're using, the native backup compression. The other option is to use something called VSS. Forgot the acronyms, virtual, shared, something, whatever, VSS. Anyway, what this means is that the third-party application actually performs a freeze of your database, of the IO, the database, make sure that the file is consistent, and it takes a snapshot of your data files and log files. It's a different mechanism for backing up. It's not using the native, not T-SQL and not the native backup of SQL Server. It's also not using the native backup compression. So if your third-party application using this, it doesn't matter what you configure about backup compression. It's not going to use that. It's going to use its own compression maybe, but it's external and they don't interfere with each other. I hope that answers the question.
I think so, yeah. And there is actually one come in just now, and
Okay.
it's going back to the idea of sharing resources on a machine. How can I win an argument with management to have SharePoint have its own DB instance instead of sharing a general purpose instance? I'm not sure whether you would do that or have to do that. I think more your point was to ensure that SharePoint, the application, the web
Yes.
service, was not running on the SQL Server, right?
Right. Right. But again, it
Just
depends.
hosting. Well,
It
true,
really depends.
true.
If you have a server that can serve both the application and database as much as the resource that it uses, it's good enough, then it's good enough. But if not, then you're gonna have to monitor and analyze the results and come up with some kind of report and graphs and show management, look, we get poor performance because of this. And if we put it in a different server, we will allow SQL Server to run properly and so on.
Exactly. Yeah. I think the point, though, to that people should recognize is we're trying to separate SQL Server doing its work from any other services. So if we had the SharePoint databases on the instance with any other OLTP, that's still not a problem directly, but having the web server that's hosting SharePoint on the same place as the SQL Server, that's where it can be a bit difficult. Yeah. And equally, and that's something that somebody's made a point as well, the max DOP setting requirements for SharePoint against other OLTP systems, maybe that's going to have an issue as well, because SharePoint requires max DOP 1.
Right. So there might be some dependencies that they interfere with other applications.
That's right. Yep. Okay. So,
all right. Let's move on. So let's talk about parallelism. So we talked about two configurations: cost threshold for parallelism and max DOP, max degree of parallelism. Okay. Those are really important, unless, of course, you use SharePoint, then it's max DOP 1, then they are not important. But if you're not using SharePoint, then let's look at an example. Let's say you have a server with 4 cores, okay? Probably have more, but just to make it simple. You have 4 logical processors on your server, and you have a bunch of queries. Let's say you have 6 queries, okay? Or requests. If you look at SQL Server at the DMVs, you can select from sysdm exec requests. They are called requests. Request is a query that is currently running. So let's say we have 6 that need to run. One option is we can take each query and use its own core. Okay, this means that each request now has a serial plan. Okay, it needs only a single core to run, to do a table scan or a join or whatever. It uses a single core for that. And since we have only 4 cores, then concurrently we can only run 4 queries at the same time. Of course, we have context switching. Okay, so the same core can serve multiple queries, one after the other, not at the same time. Okay, but if we look at it from the outside, we see much more than just 4 queries running at the same time, because we have context switches behind the scenes. But at any point in time, only 4 queries with serial plans can run on those 4 cores. That's one option. Another option is a single query can now be split into 4 tasks and run the same execution plan in parallel. The same, let's say, table scan. We need to scan a table. Now the scan can happen in parallel. So we have a single query utilizing all the 4 processors. It's split into 4 tasks. Each one of the tasks will scan more or less 1/4 of the table. Okay, they will do it in parallel. This means that the query itself will run much faster than the serial plan, but it also means that all other queries, all other 5 queries are currently blocked. They need to wait for at least 1 core to be free to run something. Again, we have context switching and so on, but it's a different model. Okay, so for a single query, you get better performance, hopefully. Not always, but hopefully, because we have multiple tasks running in parallel. But as far as parallelism between queries, okay, we get less concurrency, if I might say this way. Another option is something in the middle. Okay, so we can do something like that. We have one query that is parallel using those 2 cores, another query using a parallel plan with those 2 cores. In this case, we don't have to use all the cores available on the server. We might limit the number of cores that we use for each query. Okay, and then we can get we can win from both worlds, if you might say this way. Okay, so we have all kinds of ways, and we can control it. Okay, we control it with those 2 configurations that I just showed you. So the 2 elephants in the room are cost threshold for parallelism and max degree for parallelism. Let's talk about the best practices for each one of them. First of all, what they mean. Cost threshold for parallelism. What it means, for every execution plan, when SQL Server, when the optimizer generates a plan, it also calculates the cost associated with the plan, okay? And this configuration says it's, by default, it's 5, by the way. This means that if the optimizer generated it starts with a serial plan, always. First, it starts with a serial plan. If we have a serial plan and the cost is less than 5, less than the configuration value here, then it will go with a serial plan, and that's it. We have a serial plan, let's start executing, okay? But if the initial serial plan, the best serial plan that the optimizer can find, the cost is larger than this threshold, then it will try to generate a parallel plan instead. And now we'll get with the best parallel plan. Sometimes the cost of the best parallel plan will be higher than the cost of the best serial plan, and the optimizer will still choose the serial plan, of course, because it costs less. Okay, but in many cases, at this point, we will find a better parallel plan with a lower cost, and we will go with that. Okay, so this threshold controls the amount of parallelism, the amount of parallel plans we're going to have on the server. If we increase this value, we likely, statistically, we're going to have less parallelism because we have more and more plans with a cost that fall below the threshold and are going to be serial. Now, it really depends on the workload. In an OLTP workload, when we usually have many transactions that are short transactions, small transactions that need to just do an insert and update or a select on a primary key or stuff like that, we don't need parallel for them. Okay, they are very low cost queries. We want them to finish as fast as possible using a single core. Okay, sometimes we might, in an OLTP, we might get into situations where such a query gets a parallel plan because the threshold is too low, and 5 is usually too low. Okay, and this is why many bloggers recommend you to increase this value to at least 50 or something like that. Of course, you have to test and experiment and see what's the best value for your environment, but you usually want to increase it from the default value of 5. A better way than just saying 50 is to monitor and plan. Eitan Blumin from our team wrote a very nice blog post I think it was 2 years ago, maybe, planning to increase cost versus parallelism like a smart person. So what he suggests, and he provides the query there, is run a query against the plan cache and monitor over time all the plans that use parallel and also what was the cost of those plans, and try to adjust this configuration over time and see how they behave and where you get to the sweet spot where you have the right amount of parallelism on your server. You need to read this to understand. I'm just trying to, in a sentence, to explain it. But this would be the smart way to do it. Monitor your system over time and find the optimal value for your specific workload. I talked about OLTP, of course, in a data warehouse, in a reporting environment. This would be a bit different because then you have usually less concurrent transactions, but each one is a huge report scanning, a huge table. You really want to have parallel plans in there. So you need to evaluate, to monitor and decide what would be the best value also based on your specific workload. So that's one thing. The second one is max-DOP, max degree parallelism. This determines, if you have parallel plan, how many logical processors the optimizer is going to use inside the plan. Okay, so again, in our example earlier, we have 4 logical processors. By default, max-DOP is set to 0. 0 means SQL Server will use whatever it can. It will decide how much to use. It will usually use all the available logical processors. So you have parallel plans using 4 threads, each one. Sometimes you don't want that. You want to leave some space for other queries, just like I showed you earlier. So you might want to configure max-DOP to a lower value than the maximum available logical processors. If you just have 4 cores, it's not too much. But I'm referring you here to the Microsoft documentation. There is a table there that shows you, depending on the version, recommendation by Microsoft, how many cores, what should be the max-DOP value for your instance. Generally speaking, if you have more than 8 cores for your instance, the recommendation is to use max-DOP 8, okay, to allow up to 8 logical processors for each parallel query. And then if you have, let's say, 64 cores, this means you're going to be able to run 8 concurrent parallel queries at the same time. If you have less, then you need to adjust. Start with 8, maybe you go down to 4. Some recommend to always use half of the number of cores. Again, read the Microsoft documentation. It explains why they came with those recommendations to get a better idea of how to use it. And also, there is a difference between single NUMA server and multiple NUMA nodes on the same server. The max DOP is, you can configure it at the instance level, but you can also configure it at the database level. There is a database scope configuration. So for each database, you can have different max DOP. For example, what you said, William, about SharePoint, then you might be able to do it at the database level for SharePoint, and then in another database might use a different max DOP. You can also do it at the resource governor level. If you use resource governor, you can configure a different max DOP for each workload group if you have different workloads based on applications or logins or whatever. And also at the query level, you have a query hint. You might say, for this specific query, because I know it caused problems, I want it to run with max DOP 1 or 4 or whatever. Okay, so that's about parallelism. I can talk about for hours probably about parallelism, just an overview. Any questions?
Yes.
Okay.
What is the difference between max DOP equals 0 and max DOP equals maximum number of cores?
I think there is no difference, but I'm not 100% sure.
Yeah, I would agree. So
I think it's
max
the same.
DOP 0 just means allow me to use all available cores. And if max DOP is set to the same value, so if you have 8 cores and you set max DOP to 8, then it's basically the same thing.
Yeah. Remember that it's not. It doesn't mean always use 8. It's the max. Okay. So for some cases, SQL Server might decide to use less. But again, I think it's the same with 0 and 8 in this case.
Yep. So next question: is there an issue using an odd number of max DOP? For example, 3.
Great questions.
Yeah, really good questions.
Well, I can't tell you from specific knowledge or experience, but what I would think, it would not make sense, because if you want, just like I showed you before, if you want to have, where is it? This, okay, it makes more sense to configure an even number for the max DOP. If it's not even, that you're not going to have a balanced workload, if you understand what I mean. Yep. I think it makes more sense, but I don't have a better explanation or based on my experience.
So for me, at least, I would be concerned about the potential that the split over CPUs would go over NUMA nodes.
Right.
So I know you mentioned NUMA in passing. This is like super deep dive. That's where I would be concerned. So I would try and keep it to an even number for that reason, so that we can split it at least cleanly internally in one physical CPU or across NUMA nodes.
Yeah.
Okay.
Thanks.
And final one that we've got open as an active question: if the server max DOP is set to 1, does the max DOP query hint override this?
Yes.
Yes.
Yeah.
So
the query hint always overrides the instance configuration.
Yeah. Agreed. Okay, that's it for the questions for right now.
Okay, so we are done with this. And go to 11, best practice 11, add Tempdb data files. Okay, again, this is very common and known. By default, at least previous versions, again, a lot of things changed in the SQL Server 2016 setup. Before that, by default, Tempdb used only a single data file. Now, in the setup itself, during the setup, you can configure more. You can decide how many data files you want to use. Usually, as a best practice, you want to add more than just one file. Again, it always depends, of course, and I will show you why. In Tempdb, by nature, as opposed to user databases, we create and drop objects all the time. We create temporary tables, then we drop them, and we have many concurrent sessions doing it. Okay, so while we create tables, we need to allocate pages for those tables. So we have lots of allocation processes going on in Tempdb. And let's say we have a single data file. Inside the data file, in each data file, not just for Tempdb, we have metadata. We have allocation data files, data pages, sorry. Those pages track other pages inside the data file. Okay, so we have the global allocation map, the shared global allocation map, and also the page free space pages. They track extents and pages inside a file. So when I need to create a table in this file, I will to one of those pages and ask, where is there an empty extent that I can use to allocate for my new table? Okay, and then I will set the bit for this extent as now it is used. Now it's used already. You cannot use it anymore. So we need to read and write from those pages all the time when we allocate pages. And again, in Tempdb, we have a lot of allocation activity. So what happens is in Tempdb, let's say as an example, we have 3 sessions, 3 store procedures, the same procedure running at the same time from multiple sessions. All of them are trying to create a temporary table. Each one needs to allocate data. They are all going to access the same pages, metadata pages in the single data file in Tempdb, and then we get contention. Okay, so we get contention. We have latches. Okay, so the first one is going to put a latch on that page. It's going to read and update. Only when it releases the latch, the second one can go on. And if you have not 3, but hundreds or thousands of concurrent sessions, it's going to be a problem. You're going to suffer from poor performance because you're going to wait a lot of time for those latches and for those concurrent. So this is called Tempdb contention. It's a known issue. And one of the options, one of the things you can do in order to overcome it is to add multiple files. So just an example, because I only have room for 3 on screen, but this can be 4 or 8 or whatever, okay? So let's say we have now 3 files. Each file will have its own metadata pages. And for the sake of the example, if we have 3 sessions, then now we have this. SQL Server will split the workload as in a round robin between the data files. So the first session that needs to create a temporary table will go to the first file, the second to the second, and so on. And then we don't have contention anymore. Okay, so this will potentially solve the problem, or at least lower the risk or the amount of contention that you have in Tempdb. Again, the question should be, what should I do? How many files should I use? Instead of just telling you 8, you should monitor and see what is the level of contention that you have in your application. And based on that, you need to do fine-tuning, add more files, reduce files, and see where you get to the sweet spot. Because at some point, if you have too many files, this might also create a problem, because all of this mechanism of round robin also have some overhead. So you need to find a sweet spot for you. Robert Davis wrote a great article, a known one, with a script, a very useful script that you can use, that uses system OS waiting tasks, and it looks for all the tasks that are waiting for specific latches on those specific pages in Tempdb. And by monitoring that, you can see the amount of contention on Tempdb, this specific type of contention that you have. If you have a lot, then you might want to add more files. Then try again the query, see how it improves or not. And at some point you say, okay, this is good. I don't have contention anymore, or it's not high enough. It's good enough for me. Okay, so that's important. Again, in SQL Server 2016, during setup, you can already say, I want 8 files, and that's it. So it makes it easier. Okay, let's talk about some trace flags in SQL Server, global trace flags. So there are several that I recommend, and it really depends on the version that you use. Again, as you can see, 2016 made a lot of changes. A lot of things happened in 2016. So the first one, actually the first 3 trace flags, if you are before 2016, recommend as a best practice to enable them, because by default they are disabled, and the behavior that I will explain right now is not present in your system. Starting with SQL Server 2016, all of these 3 are by default enabled. This is part of the database engine. This is how it behaves. Okay. The 4th one is still relevant today. So let's take them one by one. 1117 means if you have multiple files in a file group, and you need to increase. There is an auto growth, for example, for one of the files. All of the files will grow together. So assuming they are the same size, they will be filled up at the same time. They will grow together at the same time. And this is what you want if we talked about the contention. And this is another way to fight this contention. You want to have multiple files. You also want the files to be at the same size at all time, because this round robin mechanism that I talked about takes into account the amount of free space in each file. So if there is one file that has more free space than the others, it will get more connections, more queries. It won't be balanced. Okay, so you're still going to have contention on that file. So you want to have multiple files, you want them to be the same size, and you want them to grow together. If you are before 2016, you want to enable this trace flag. Starting with 2016, this is the behavior of Tempdb by default. 1118 is also important for the same scenario, for the same use case. This talks about mixed extents versus uniform extents. When you allocate pages for a new table, so by default, before 2016, the allocation is for the first 8 data pages, it's going to be from a mixed extent. A mixed extent is 8 continuous pages, and each page might belong to a different table. As soon as the table has more than 64K, which is 8 pages, it will start allocating uniform extents, complete extents of 64Ks each time. Using this trace flag, we're not going to use mixed extents anymore. Each allocation, even the first one, will already start from a uniform extent, which is better because you have less allocations activities. So again, less contention in Tempdb. So again, starting with 2016, this is default. If you are before, enable this trace flag as well. By the way, to enable trace flags, global trace flags, go to Configuration Manager, go into the service of SQL Server. One of the tabs there is Startup Parameters, and you need to put there -t and the number of the trace flag, and of course restart the service, and then it will go into effect. The third one is interesting, 2371. This controls the threshold when statistics should be updated automatically. So by default, SQL Server updates statistics automatically unless you change this behavior. And there is a threshold. So before 2016, without this trace flag, the threshold is 20%. So if you have a table with, let's say, 1,000,000 rows, and you've just updated statistics, after 200,000 rows which are modified, inserted, updated, deleted, 200,000 rows that are modified, at this point, you have 20% changes. This will trigger automatic statistics update. In many cases, this is not good enough because the frequency of updates is not good. It will take a lot of time until the next time you're going to, or SQL Server is going to automatically update statistics. 2371 changes this threshold. It's not a specific value. It changes dynamically based on the table size. So as the table becomes larger and larger, the percentage goes down. Okay, so the frequency of updates stays more or less the same. From my experience, from other experience, in most cases, this behaves better than the default behavior before 2016. So the recommended best practice, and this is where you really need to test because it might be different for your environment, but the best practice is usually to enable this trace flag before 2016, or again, starting with 2016, if you use the compatibility level of 2016 onward, this is going to be the new threshold by default. And the last one, through 226, has nothing to do with performance directly. What it means, by default, when you backup a database, either it's a full backup, differential, log backup, you have a message in the SQL Server error log saying backup completed successfully. Now, if you have a server with many, many databases and you run log backups for all of them every 5 minutes, you're going to have many, many messages that you really have nothing to do with. You don't need them, okay? They just fill your error logs. And then if you need to find something in the log, it might interfere with your analysis. So this trace flag just said, don't put those messages in the log. And usually we don't want them. So just I use as a standard guide whenever I set up a new SQL Server. I have a checklist. One of them is just to enable this trace flag, put it in the configuration manager, and that's it. 3226, and this has not changed as opposed to the other ones. Even today with SQL Server 2019, if you want to suppress those messages, you need to enable this trace flag. There is no other way to do it. Okay, so this is about trace flags. Any questions?
Yes, so there is one question around the first 2 trace flags on your slide.
Yeah.
Do they just apply to Tempdb?
So I think, yeah, both of them, I think both of them just apply to Tempdb before 2016. In 2016, they are replaced with, you have alter database command. Part of the alter database command is, I forgot the syntax, but as part of the alter database, you can change this. And in 2016, by default, this is the behavior of Tempdb, but this is not the behavior of user databases. So you can still change the behavior of user databases, but not with the trace flags, rather with the new alter database syntax, which I currently forgot the syntax. Before 2016, if I remember correctly, these trace flags only relevant for Tempdb.
Okay. Let's see. Yeah, so I wasn't sure either, but just quickly checking.
Okay.
They both work for the entire instance and for all databases,
All right.
but those two have a huge impact on Tempdb itself.
Yes.
So usually
They
you
are
don't,
meant for Tempdb. This is the
yes,
motivation behind it.
but they work on all databases. But the issues
Okay.
that they solve are usually not something that you see in a user database. It's
Right.
usually a performance problem in Tempdb specifically.
Okay. So thank you for that.
No problem. We got a couple more now.
You
What
see, I learned
about
something new.
That's right. You said at the very
Yeah.
beginning you
Yeah.
would learn something.
There you go.
So, what about collation inside Tempdb?
So again, you can't control directly collation in Tempdb. It inherits from the server collation. So Tempdb uses the instance collation that you specified during setup.
But having a different collation between databases, you need to be very careful with those things. It's possible to do, but you need to be careful, that's for sure. And we have here a final question, at least active one. Are there any recommendations for locked pages in a memory setting?
Wow, that's an old one. I haven't looked into this one for a long time. When we used to use 32-bit applications, SQL Server 32-bit, it was really relevant. In 64-bit, I think, I really don't know. I think the recommended best practice as of today is still to enable it, but I'm not sure about that. Sorry.
Yeah, so on at least on the Microsoft documentation, it says that it can be turned on, right? Locking pages in memory may boost performance when paging memory to disk is expected. So this is more of an issue if you're going to be hosting multiple applications onto one
Yes.
server itself. So if we're dedicating this one Windows machine to SQL Server, then there's very little chance that another application or service is going to try and steal memory from SQL Server. So yeah, this was usually an older setting when there was memory contention and multiple services running on one machine. The best,
I guess
better,
the
or the
interesting question
better.
is,
Yeah,
sorry.
go for it. No, go for it.
I guess the interesting question is, what is the downside? So if it might boost performance, what might happen if I enable it? And
Right,
I'm not
so
sure.
enabling it is not going to necessarily cause problems, right? This the memory that SQL Server then reserves for itself is not going to want to give that up. But if we have nothing on the system trying to take memory from SQL Server, then nothing's going to happen, right? So somebody makes a good point in the chat. Lock pages in memory could be useful if we're running multiple instances on one machine. So,
So again, multiple instances is again just like running an instance of SQL Server and something else. Then they need to compete for resources.
Exactly. So it's all further tools to allow you to control who gets what and when on a system. The absolute ideal and easiest way to control a system, have one Windows machine, or now with brand new SQL on Linux, one Linux machine, and only run SQL Server. Only have that machine doing SQL Server work. Then you're not going to be arguing and fighting with other instances or other services trying to steal resources from you.
Right.
Okay, that's it from the active questions or messages.
Okay, so I think this is the last one, number 13, manage SQL Server error logs. Again, it's not specifically about performance, but from my experience, I think it's important. And actually, I actually have a demo. This is the only demo I'm going to show you today. It's the last one. So by default with SQL Server, you have the SQL Server error log, and we have 7 rollover files. We have 7 files for the error log. Every time you restart the service of SQL Server, it will end the previous file, it will start a new file. They are all located by default in the error log, the directory of SQL Server installation. And of course, we need the error log when we need to troubleshoot and see if we have problems, we have errors in SQL Server, things happen. We want to look in the error log and search for them. And the problem is, if your SQL Server is in good shape and it's been running for a lot of time without any restart, you might have a very large file for the past few weeks or months, or I don't know. And on the other hand, you might have several restarts because of all kinds of reasons. Okay, you did some testing or failovers or I don't know what, and you might end up with 7 very small files only for the last 2 days, and you lost all of your history. Okay, so this is not a good way to manage your logs. And you don't have to use the default. You can control that. You can do 2 things. One of them is increase the number of files. My recommendation is to 30. Of course, you can choose whatever you like, not just 6. Okay, we have 6 and also the current one, so it's 7 altogether. You can increase that to 30. And the other thing, put a SQL Server agent job that runs every day at midnight and cycle the log. We have a specific stop procedure for that, SP cycle log, which will start a new file. So this way, you don't have to wait for restart. You can control it yourself. And then if you're doing this, assuming SQL Server was up and running in the last month, then now you have a nice bunch of 30 files, a file for each day in the last 30 days, and you can better control and investigate the error logs this way. So this is my recommendation, a short demo. Here it is. Okay, so what you can do is run this. This will show you all the files. Of course, you can do this through the GUI as well, the user interface. You can see the file that I have right now. I added another one just before the demo, just to make sure that it's working. Okay, so by default, you will not have the 7th file because I have 8 right now. And you can, again, you can do this through the GUI. I prefer to use scripts for everything because then I can easily reuse them. So there is a script. There is no specific T-SQL command to change it, but you can change the registry by running this code, and you change it here to 30, for example. Okay, and then you can use this SP cycle error log. Okay, and if we look again, then as you can see, now I started a new one. Okay, and I have another one, and as more and more files get into this list, I will have 30 files. When I get to the 30th file, I'm going to cycle the first one again, and so on. And I have a code here just to create a job. The job has a single step, and the step does SP cycle error log, and it runs every midnight. I will not run it. You can understand what it does. So this is my recommendation about the SQL Server error logs. Okay, don't use the default 7 rollable files only when there is a restart. So summarize, we talked about all kinds of best practices, and I'm sure there are many, many others. I'm sure you have some, all of you have more ideas, but we need to finish at some point. Those are the main best practices that I use when I install a new SQL Server, the things I do. Again, let me just summarize some things you need to do before at the planning phase. You need to plan what version addition, how much storage you're going to need, what is the spec, and so on, before you even start installing SQL Server. There are all kinds of things you can do you should be doing during setup, like configuring the max memory, the number of Tempdb files, choosing the appropriate services and components that you really need, and so on, the collation of the instance. And after, there are many things you should be doing after installation. Some of them you're going to do right after installation, like enabling global trace flags. Some of them you need to do over time. When an application is running, you're going to be monitoring, and then based on your monitoring and analysis, you're going to decide what should be the best values for cost threshold parallelism and max stop, for example, and other things that we talked about here during the session. And I think I'm done. Okay, we're done with those.